Hey, hello everyone, and welcome to the session. As promised, every Friday, we will be having this discussion, and we are going to explain you about the live projects which we have done in the past, and you will enjoy understanding the project end to end, and you will also experience the practical implementation. And we are going to demonstrate end-to-end implementation so that you understand the entire data pipeline. This is our objective. Okay, so here is the agenda. We will understand the project overview and the scope, and then we'll understand the objectives and constraints, CRISP MLQ methodology, what was the technical stack which was used, what was the project architecture, how did we pull the data? How did we deploy the model in production? How do we serve the model in real time? Everything. And also then starts the journey of collecting the data, describing the data, understanding pre-processing, model building, using hyperparameters, evaluating your model, then deploying the model in production, and finally conclusion. This is how the project would be structured. Here is project MLQ. You need to understand the business aspect of the problem that we are solving, as well as you need to thoroughly understand data. How much data is given to you? What is the dimension of the data? Okay, and multiple other things, right? And what are the various data sources? What is the rate at which data is getting generated? All of this. And we then move on to data engineering aspect, wherein you establish the connection between different applications, you pre-process the data so that your data is valid and it's good enough for you to build the model on your data. Once you build the model, you test and evaluate to see whether your model is of good quality or not. Then comes model deployment. And then after you deploy the model, you need to keep checking the results. You need to monitor and maintain the model on an ongoing basis. And once you feel that the model is valid, you continue using. If you feel that your model is giving incorrect results, that is, model drift, or if you feel that the data on which you built your initial model has changed, then you need to retrain your model. What is this project all about? What is the project overview? So to explain that, our participants have also worked on this aspect. So governments across different countries, they anticipated more lockdowns. This is about during lockdown or after first lockdown, what happened, right? A lot of organizations wanted to really understand the well-being of primary school children during lockdowns, because they were not allowed to meet their friends. They were not allowed to play in the play areas, play environments. So what was the mental well-being? A lot of countries were really concerned about this, because these are the people who will grow and then start leading the organizations, and they'll become future leaders. They have to drive the country. They have to drive the nation. If the younger generation well-being is not taken care of, then the future would be in jeopardy. So the task that was assigned here was to determine the well-being of the young children. And we also wanted to remove the biased interpretation. So we had to use statistical models and then build prediction models to predict the well-being of the young children, and also determine what are the factors which are important for a children. Maybe the adults, parents are not aware that these are the factors which influence the mental health of kids. So there was a questionnaire which was filled by actually children, primary school, with parents' consent. Confidentiality is extremely important because it's kids' data. They might be wrong. Maybe their understanding wasn't right. Maybe they speak out their mind. Who knows? So it has to be safeguarded. Otherwise, kids might be bullied based on the responses they give. So we have to look at all those aspects. And hence, data was masked. Only the answers for the questionnaires is provided. However, questionnaires, of course, we have access to it, but we will not be demonstrating it to the outside world. So parents are also invited to complete the questionnaire about their children. It's not just children with parents' consent, but also parents can fill on behalf of their children, because we are talking about primary school kids. Okay, and a lot of things was done, and a lot of softwares, etc., were used in analyzing this. So let me move on to this. Our main goal is to identify what are the factors which influence the emotional and behavioral well-being among kids. How were basically young kids impacted during pandemic, during lockdown? The data set is related to medical field, and hence it is considered to be sensitive because it has PHI data, personal health information, and it also has PII, personally identifiable information. Okay, so we need to safeguard the data. It is as simple as that. And these are the various things which were used. Where is my scribbling pad? Yep, I got hold of that. So obviously Python was used for as a statistical programming language. It was used for fetching the data from SQL database. And then you perform the data pre-processing, model building, and bunch of that. We have, or the team has made use of GitHub and Microsoft Azure, okay, to perform the deployment part of it. Of course, there was SQL Server, which was used. So we will show you how from SQL Server you pull the data using Python. How do you run all the lines of code? And how do you actually deploy the model in production? For deployment, it was done on cloud on Azure. Okay, and even before that, we also have taken the data into Tableau to perform descriptive analytics. A lot of descriptive analytics can be performed with ease using your BI tools such as Tableau. Okay, of course, you have Power BI, Click, and bunch of those, but we have resorted to Tableau. And when it comes to deployment, there are two ways of deploying. One is, of course, we are going to showcase on Flask. And then we have used HTML and CSS, which is a web framework. Combination of these will help you come up with a web framework on which you can deploy a model, and then you can visualize the results. However, Heroku also was used. Usually what people do is, my dear friends, for proof of concept, okay, even before you start embarking on the journey of coming up with the full-blown model, you do a proof of concept first. When you do proof of concept, usually Python Flask is used. And once you're happy with the proceedings, then you end up using something like Heroku. And we'll also showcase on how to use Heroku. Hands-on will be done next week, same time, but today it will all be theory. You will understand the theoretical aspects. And here we go. So we have stored the data in the database. We had survey questions which people have filled. Responses would come in Excel format. Okay, but that data maintaining in Excel doesn't make sense. So we have actually placed the data in SQL database. From there, we fetch the data into Python. We performed data pre-processing, which includes all these terms, right? Such as data transformation, data reduction, data cleansing, data integration, things of that kind. We have performed feature engineering, and then we have using Python used a lot of data visualization libraries such as Matplotlib, Seaborn, etc. Then we build the model. After building the model, we deployed the model on cloud. Okay, once we have deployed the model on cloud, we started, giving a user interface to the end user, wherein the end user can key in the inputs and then just click on submit, and then the results would get displayed on the screen. Not just that, all the prediction results have to be written back to the database. All the prediction results are written back to the database so that in your database, over a period of time, you have your output variable and input variables pertaining to the new data. You already will have your historical data. Say you have 10,000 observations and new data keeps coming in. 10,001, 10,002, 10,003 in that way. As in how you keep getting the inputs, your model will keep predicting. And then the predicted variables also are filled in this column. Now this eventually becomes the new data for you. If there is any data drift, meaning this variable X was following a normal distribution when you trained the model using these 10,000 observations, but eventually the new data for this variable X1 was say skewed. Data drift happened. So you need to retrain your model. All these things we are going to demonstrate live in action. Okay. For now, we are understanding the entire project, architecture, etc. And next week, we will run the code, okay, and then understand how the project was practically implemented. So data collection. Data collection is one of the very important steps, and mostly in the projects, when you collect the data, it would be using secondary source. You use secondary data sources. However, in this specific project, we have resorted to primary source, which is conducting the survey. Okay, we have conducted surveys, and surveys have questions. And people fill those questions. They answer the questions. And when the questions were, responded to, who have responded to those questions? Both children, primary school children, and those children who are very young. Okay, parents of those children have also contributed to this. First, data from your SQL database was uploaded to Python, and then pre-processing happened in Python, right? And we, the team has also tried out without putting the data directly into SQL. They've also taken the CSV data directly into Python, and they've also done some pre-processing. Okay, next, what happened? So we have seen that the data was semi-structured data. A few of the variables were structured. A few of the variables were unstructured in format, basically, right? And a simple questionnaire, basically, you'll have questions and then responses. Right? This had 987 rows. When people ask you, hey, what was the dimension of the data on which you have worked upon? You have to say that dimension of the data set was 987 by 60. dimension of the data set. Okay. Sorry about my handwriting. The scribbling part is not working well. Okay, means that aside, there were 987 rows. That means 987 responses. And they all responded to 60 different questions. Certain questions had sub-questions. So overall put together, there were 60 questions, including the main question and the sub-questions. And when people fill the survey, they are not enforced to answer all the questions. They need not answer all the questions, especially when you have survey data. It's up to the discretion of the person. They might opt to fill a few questions or respond to a few questions. Okay, to a few questions. And they might want to not respond to certain other questions. Wherever there is no response, that becomes your missing value. And whenever you have your missing values, you might want to impute those missing values. Impute means replace the missing values with some logical value. Okay, there were a lot of there were some NaN values, and majority of the data was categorical. Discrete data categories were there, like you have gender, male, female, right? In that way, a lot of categorical variables were there. And I'll show you the data as well. And the target variable was to predict the emotional difficulty subscale values. And there was also behavioral difficulty subscale values. Values range, I mean, there is a big range. Okay, there is a lengthy range of values that your model has to predict. Just to give you all a sense on the data, let me show this. So all these are categorical variables. I'll just show you this. How many people live in your home with you, including adults? The count is given, 5, 6 plus, so on and so forth. So this is all categorical data. Then, do you have any other children living in your house with you? A few people are saying yes, a few people are saying no. In that way, all these are the questions. Okay. And why is it called as semi-structured data? If you look at this question, if yes, how are you keeping in touch? Okay, here, are you able to keep in touch with your friends? If yes, how? By phone, texting, calling. Look at the responses, right? This is all textual data, but rest all, it is categorical data, but it's not textual in format. And certain other questions such as what above places do you play in? It's again textual data. So it is semi-structured data. It's not completely structured. So you might have to perform your text mining to convert this kind of data into structured data, unstructured to structured, or if these are limited categories, limited options which are selected, then you convert this into one hot encoding or some kind of label encoding as needed. Back to our discussion, and we will have to predict the emotional difficulty subscale, etc. And let me move on. This is the data basically framework. Here are the various variables, and whether that variable is nominal or ordinal, or is it continuous data, all of that is already mentioned. Okay, these are all the various questions which were asked. They eventually become your inputs. All these questions. How often do you play? Enough time to play? Do you have enough time to play? Things of that. And people will give rating, or they're going to select the option. So in data pre-processing, the team has applied some steps, right? They took the raw data. From that, the structured data they have taken out, and they have done data pre-processing, which is and then they performed exploratory data analysis, and they have understood the various graphs. A few things, a few of the data pre-processing things that happened was, a few of the variables which were continuous were converted into discrete buckets. Okay, a lot of things are there, a lot of basically options are there. And then label encoding also was performed. Label encoding means we replace a categorical value with a numerical value. This is how it is. So if you see, for this specific question, no, I'm at home, so is 1. For example, here, are children living with you? Yes means 1, no means 0. And you have year 5, year 4, year 6. So 1, 2, 3, in that way I have converted it into label encoding. Before label encoding, this is how the data looked like. After label encoding, this is how the data was converted. Okay. And there were some mappings for some columns like breakfast eaten, all places to play, etc. I mean, these were a few columns wherein some kind of mapping was done, and sleeping times for children was calculated. What time did you fall asleep yesterday? What time did you wake up today? If yesterday you slept at 9 p.m. and you woke up at 6 a.m., if you subtract those two, you get to know how many hours the kid has slept. Okay. And some mapping for some columns, right? For example, breakfast eaten. There were different other columns, and those different other columns were combined to give this breakfast eaten. Change the attributes name according to convenience. Okay. A lot of columns were there. The names were appropriately renamed. And the columns such as year, month, day, etc., which actually did not make sense in this scenario, was removed. Maybe, without removing these columns, you can also look at seasons. Was it summer season, winter season, spring season? What season was that? Okay. Was it summer, rainy, spring? What season exactly was that? Also can be taken into consideration, because in certain seasons, maybe people behave differently. We don't know. Right? So that is what has happened here. And then this is what I was talking about. These are the output variables. 2 different models were built as part of this project. In one model, emotional difficulty subscale was output. In another model, behavioral difficulty subscale was the output variable. If the scores were between 0 and 9, it's considered as expected behavior. If the scores are between 0 and 5, it's expected for behavioral analytics. If the scores are in between 10 and 11, it's called as borderline difficulties. Then score of 12 and above indicates clinically significant difficulties is what kid is experiencing, emotional difficulties. When it comes to behavioral difficulties, scores of 6 indicate borderline difficulties. 7 and above indicates significant difficulties. To be able to categorize in this way, to be able to bucket in this way, to be able to discretize in this way, all mean the same way. You need domain knowledge. And whenever you're working on projects, you're expected to do thorough research on the project. Because there'll be a wide variety of business problems which you as a data scientist will solve and should solve. No escaping from this. You cannot say that, do you know what, I know only about manufacturing, assign me projects only on manufacturing. No, that is not how it works. People expect more from you. So they expect domain knowledge, industry experience, sector experience. How will you accrue that? Simple, by doing research. What are the various projects which were built? in this space? What were the output variables? Right? You do a lot of research and gain experience. After you gain experience, yep, you'll continue working on that. Okay, most often than not, research happens to be the number one, uh, business skill which one has to possess. Okay. So here, emotional difficulty subscale. Under survey question number 24, there were 60 questions altogether, right? Under survey question number 24, there are 16 subpoints. Out of that, the first 10 questions belong to emotional difficulty subscale, and which can be measured using the scores like this. And this is how the data would appear. Here you have the output variable, expected, significant, okay, borderline, so on and so forth. For behavioral difficulty subscale, under survey question number 24, again, there were 16 subpoints. And out of that, the remaining 6 questions were related to behavioral difficulty subscale. And you have the details given here. Only I am calm is given a reverse score. Otherwise, everything else is given 0, 1. And these are all the various inputs, and you have the output, which is behavioral output. And then you have data analysis. Data analysis is defined as a process of cleaning, transforming, and then modeling the data to discover useful information for business decision making. And data visualization also was done, which everyone has to do, on health, on family, on appearance, on friends, on life, everything was done. And it's not about just running these graphs for the fun of it. The moment you run, you need to glean meaningful information from those visualizations. For example, when it comes to health ratings, if you look at this histogram, most of the children keep their health in good condition. That is what it means. Because the mean or median is 9, which means that they maintained their health in a good way during the lockdown. But a small proportion of children suffered from the health problems. If you look at this 4, 2, etc. Family ratings. Most of the children spent valuable amount of time with their family during the lockdown. Median is 10. Appearance rating. Most of the children believe in oneself, meaning being individual. As we observe from histogram, most of the children have good bonding with their friends. Life rating is most of the children had good growth in their lives. But all these histograms, if you see, are left skewed, which means that the children who were under the survey, their health was in a good condition during lockdown. And then our team has figured out that they can build multinomial logistic regression to predict the categorical data. Okay, it's not logistic, though it's named in that way. It's multinomial logistic regression, which was actually used. And when they have built, as I've told you, there are 2 different models which the team has built. Model 1 was on behavioral analysis, wherein you have test accuracy and training accuracy, and F1 score. F1 score is the best measure. It looks at both precision and recall. It's 2 times of precision into recall by precision plus recall. And this F1 score value ranges from 0 to 1. 1 being best. So 3 different models were built: multinomial logistic regression, random forest, and then SVM. And team figured out that this was something which can be considered as a best model because it also has interpretation capabilities. Then for emotional analysis, the team has tried building 4 different models. While you're not always expected to use that model which gives you the highest F1 score, not needed. Sometimes you also need to look at, do I have another model which has better interpretation? So SVM is a black box technique. It doesn't have good interpretation. However, if you look at multinomial logistic regression, it has good interpretation. And hence, this model was used or selected out of all these models, despite knowing that this multinomial logistic regression accuracy was the second highest. And this is how the model deployment happened. All the details, data, the model, you have data, you build model. From that, you get the pickle file of the model, put it in GitHub. All the various things such as what were the various libraries used, etc. Along with the other details needed for your Flask application, I put it into GitHub. And then from GitHub, you take the data into Microsoft Azure and you do the deployment part. So create ML model and save it. Create Python flasks for user interface and Python main file, which is app.py. This can unpickle the model. Pickle means it will zip, right? Kind of. Unpickle means it's going to unzip. And then use a model for predictions. This is how you save the regular models, traditional models. Friends, you can use traditional ML models, or you can use deep learning models, deep machine learning models. Here, usually you save the models in .pkl format, pickle format. Here, if you use something called a TensorFlow, you might want to use in .pb format. If you use Keras, you will have the model in .h5 or .hdf5. If you use PyTorch, I think it's .pth. So in this way, there'll be different formats depending on which framework you use, okay, or which model you actually use, right? And then you create the requirements.txt to set up the web Flask application, wherein you'll mention about all the Python dependencies, etc. And then you create proc file to initiate Python app command. Then you commit files from our above steps. I mean, you take those files and put it into GitHub repository. Once done, you create an account on Azure. There is an app that you can create. We will demonstrate all these things next week. Then you connect with GitHub repository, select the branch, and you manually deploy the model on Azure. At a high level, these are the steps needed for deployment. However, when we showcase this to you guys next week, we will also showcase on Heroku. Next week, we'll also showcase on Heroku. Okay. And remember from our project objectives, another objective was, out of all these questions which were asked, you got a lot of responses. Based on that, tell me, what are the most important features which will have an impact on the mental health of the kids? And the team has used something called as RFE based technique, recursive feature elimination, which assigns basically a score, and those variables which have high score should be considered. And these are the features basically which were considered to have good impact on the output variable. So here is a conclusion. Okay, I leave this conclusion for you guys to explore further. time to play, sorry, time to play was a feature which had most influence on behavioral score. And children having adequate time to play were showing normal behavioral traits, normal behavior. Location of the child's home, if it is near to play area or the park area, it had a direct impact on behavioral aspects. They were actually a lot more healthier when it comes to mental health. Children who can easily walk to the play area from their homes showed normal behavior in comparison to children who stayed far away from play area. Apart from this, eating habits were also considered. And in order to improve the behavioral aspects, special attention needs to be given to physical exercise in the form of play. And you need to obviously give appropriate diet. Okay, children having more friends tend to display expected or normal behavior as opposed to children having less friends. All these were the insights which were gleaned, which were inferred from the analysis. And the frequency of outdoor playing activity had a fair degree of influence on emotional aspects as well, not just behavioral aspects. During the lockdown period, it was quite natural for the kids, because they got lonely, they missed their friends, they missed the playtime and all that. So any other way that the parents can engage with the kid would actually be very beneficial. While these were a few insights which were drawn, the key thing for you as a budding data scientist would be to understand this architecture. How the data is being collected, how are you loading that into Python, how are you doing pre-processing and feature engineering, and what kind of visualizations you're drawing, and what insights you're drawing from that. Then you build the model, what kind of models were experimented, what kind of hyperparameters were tested. Then finally, where are you deploying it, and how are you serving the model, or how are you using the model in inference phase for obviously future purpose. Right? So these are a few things that we had for discussion today. And next Friday when we connect on the same project, we are going to look at practicals, hands-on. Okay, we will show you end-to-end implementation in a practical manner. Please subscribe to our YouTube channel and ask your friends, relatives to actually subscribe so that they benefit from this. Every week, we are going to talk about one live project and also the practical implementation of it. Okay, sometimes on the same day, we will explain about the theory and we will also look at practicals. In certain other occasions, theory and practicals will be segregated. Okay, so welcome to the era of democratization. We are trying to democratize the projects that we have worked upon. Thank you so much once again for being patient and listening to the session. And more to follow next week, same time, 6 p.m. onwards, IST, next Friday. Thank you all. Until then, have a great day. Keep learning, keep upskilling, and keep growing. Thank you all.